Okay, here is what a reflection looks like. I'll show you what to write down in just a second. This looks like something very, very confusing, so I wouldn't write down what I don't even know it says, okay? If you don't understand what it says, don't write it down. So if you reflect something, it flips over that thing, right? You can think of a mirror. You know what a reflection is, right? But if it's reflected over something, it's just flipped over it. A lot of times people use the word flipped when it should be really it's reflected. You'll notice, let's see. Oh, they have the word pre-image and image. Your pre-image is the first one. Your image is your new one, okay? And let's see. I thought we had some formulas, but I'm not seeing any yet, really. Let's look at this first problem. Okay, this is what I wanted to show you right here. This is what I was looking for. This capital R, see, everybody see that capital R? That means a reflection. This y equals 1, that means you're going to flip it across the line y equals 1. That's going to be the hardest part. If you flip something across the x-axis, y'all, that's super easy. Okay, if I flip it across the x-axis, let me just draw, oh, here's a graph. All right, I'm going to change our problem up really quick and do an easy one. Let's pretend that I have this point right here. If I flip that across the x-axis, that's super easy. Where does it go? Where's the x-axis? Here's my x-axis. So if I'm one space from my x-axis, where am I going to go on the other side? One space. Here's my new point. Does everybody understand flipping it across the x-axis? That's easy. Okay, let's do the y-axis really quick. Let's have everybody understands this is the y-axis. Yeah. Let me draw a little triangle. Okay. Let's draw that triangle. If I'm going to flip that triangle across the y-axis, that's also easy. Here's my y-axis. It tells me right there that says y. That's my y-axis. So if this one is one space from the y-axis, then I've got to flip over here one space. Everybody get that? If this one is two spaces from the y-axis, that's going to go two spaces. This one, see how, doesn't it look like a reflection? It better look like a reflection. Okay, it better look like it's just flipped across that line. Are we good with that? Yes. Okay. Now, let me draw our problem. Our problem is at point 3, -2. Over 1, 2, 3, and down 2. Here's point P. Is there, everybody sees point P? We want to make a new point P prime, and it says they want us to reflect it across the line y equals 1. And they'll say point P. Did they put that in parentheses? They did. This means, hey, take point P and reflect it across y equals 1. That's not the y-axis. That's not the x-axis. That's where it's a little bit harder to figure out. Y'all, but it's not bad. Where's the line y equals 1? Where's 1 at on the y-axis? Right here. What did I do? Instead of starting here, what did I do? I went up 1. That is y equals 1. Does everybody see that? Every one of those points is at y equals 1. So if I'm going to flip P across that axis, I am 1, 2, 3 spaces from it. So how many spaces am I going to go on the other side? 1, 2, 3. Here is what we would call P prime. And maybe it wants the new ordered pair. Okay? So what's my new ordered pair? Let me erase that. So it's at 1, 2, 3, and up how many? 1, 2, 3, 4. I'll do some more of these. Okay? Do we kind of understand that though? X-axis and y-axis are easy to figure out. All right? Let me make up another one. I want us to take point A, and I want us to do a reflection over the line x equals 3. And I'm going to say point A is right here. There's A. Okay, let me write A. Where in the world is x equals 3? Okay, that's not my x-axis, that's not my y-axis. So let me go over to x is 3. That's right here. So guess what? That's that line. Oop. Okay, let's go back. How many spaces am I away from that? So I'm going to reflect over it 1 space. There's my new point. Oop, it's A prime. I read that backwards. Maybe I want the ordered pair. So for my ordered pair, I start here and I go to the right 2 and up how many? 1, 2, 3. Maybe it wants my answer. Okay, does everybody get that? You just have to know, where are they telling you, what is it reflected over? You have to read that and understand what it is. If it says x equals, it's a vertical line. If it says y equals a number, it's a horizontal line. Okay, everybody good with that?
I'll already have the first point on there.
Yeah, or a figure, like we might even get to like triangles. It's super easy when it says, let me find another one, but they're really easy if it just says this right here. What does that mean? I'm going to reflect it over the x-axis. Well, that's obvious. That line is drawn for me. Okay, there's one other one that's hard. So I'll show you this last one, and then I'm going to go through examples from the book. Some of them I might repeat. I'm kind of just doing I'm off on my own thing right now. The only other thing I can think of is, okay, you've got x equals, which is a vertical line, or you've got y equals a number, which is a horizontal line. You've got your x-axis, and you've got your y-axis. The only other crazy thing is, what if it said y equals x, a reflection across the line y equals x. And you should, I want to say you should know this. It took me, like, I was in college before I could just remember what that looked like. Okay, I wish somebody would explain that one better to me, but y equals x is just this line right here. Because if x is 0, y is 0. If x is 1, what's y? 1. If x is 2, what's y at? 2. They're equal. That's always the line y equals x. What's the line y equals negative x? It's this diagonal. Okay, anyway, they might throw that one in there. I don't know that I do, like on your test, because there's so much to go over for your test. But say I might reflect it across that one. Is everybody good with that? I think I've got a rule for that one though. We'll get to that in a little bit. Okay. Questions? We're good? All right. Let me do some examples from your book. I already did that example. Okay. So here we go. All right. They want us to do this one. All right. This is good. This one is not just a point. Okay, this one says, hey, graph these 3 points. 3 points is going to make a triangle. All right, and then it says, reflect it across the what? Y-axis. Oh, good, because that one's easy. So first thing I'm going to do is plot those points and draw my picture. All right, Lakin, you getting all this so you won't have a dozen questions for me? Okay, good. So negative 3, 4. So we go left 3 and up 1, 2, 3, 4. And I'm going to label that point A. Point B is 0, 1. Here's point B. And C is over 4, 1, 2, 3, 4, and up 2. It's kind of a big triangle. Okay. Everybody good with that? Now it says reflected over the y-axis. That seems like, gosh, that's going to be difficult. Y'all just do 1 point at a time. Okay, you're literally doing 1 point at a time. I'm wanting to say what they do. Oh, I think I can give you a formula. But I just count. I just count each point. To me, that's the easiest thing. How many? Here's my y-axis. I am 1, 2, 3. So I'm going to go how many? 1, 2, 3. Here is A prime. Right. It flips on itself. That's fine. Okay. This one is how many spaces? 1, 2, 3, 4. So I go 1, 2, 3, 4, and that is C prime. This is 0, so I'm going to go 0. Right? It just stays there. Flips on itself. And so the red. Oh, let me write B prime. there is my reflected triangle. It's just kind of flipped over it on itself. Do we understand that? Okay. Let's compare ordered pairs. Like this one was -3, 4, 0, 0. And then this one was 4, 2. If I flip across the y-axis, this becomes 3, 4. This becomes -4, 2. And that stays 0, 0. It looks like all you do, if it's reflected across the y-axis, is your x value becomes the opposite. That's it. Okay, I don't know if you want to memorize that rule, or would you just rather graph it? Yeah, I mean, graphing is great, but all you do is you change your x value to the opposite. The y value stays the same. You're just flipping that x value. 0 can't be changed, right? But a -3 becomes a +3, and a 4 becomes a negative. Either way you do it. Okay, everybody good with that? Is that easy so far? Or not easy, but doable? Okay. You just plot points and then count. Okay, let's see what else I have. Oh, that's stuck. Do I need to do one over the x-axis, or do y'all think y'all can reflect over y or over x? This one says to I don't need a graph. It says write a reflection rule. So they want us to look at this picture up here. I've got my two lines are what? M and K. And they want us to write a reflection rule for going from triangle 2 to triangle 4. So what would you write? First of all, a reflection rule has a capital R. And what did it reflect over? Yeah, line K. You're going to reflect to, I wonder if they want me to put, triangle 2 is a reflection across line K. They don't really, they just kind of explain it. Hold on. They put triangle 4, I guess, is what they're going to do. I would just do this, triangle 4. Or maybe I'm just going to put actually triangle 2, because that's where I start. I'm going to take triangle 2 and I'm going to reflect it over what? Line K. All right. I think they did, their problem was worded the opposite. Okay, are we good with that? Reflection rule is R, line K. What was the translation rule that we've learned? Capital T, and you put that, and maybe it was like triangle ABC. All right, it's whatever you're moving. That's what you write. Like I was moving triangle 2, okay? They put triangle 4 because they were reflecting triangle 4. I did the wrong problem. So anyway, let's see if I have one more thing. This says, I'm not going to do that. Okay, so let me look and see what's on your paper. All right, how we feel, I guess, good. What you can do is finish, well, either one, really, first.
So I have a question about the triangle or like the shadow. Do we have to do it at 4 different times, or can it
Yes.
be like 1 o'clock one day and then 1 o'clock
You
days later?
4 different times, because at 1 o'clock it's going to be the same answer both times, or it's going to be like really, really close to the same answer. Because that'd be like, if you did that several times, that'd be doing the same problem. So like if you did, because y'all did it during this class, which yesterday, I don't know if any of y'all went out, it's still not due until, what did I tell y'all, Wednesday or Friday? Wednesday? Okay, so I don't think it's going to be sunny today though, like I at all. That's why I pushed it back, because I was thinking yesterday there was no way y'all could do 3 different things. So y'all probably won't have sunshine for the rest of the week. So if y'all got Monday, y'all have got Tuesday, and I mean, if for some reason you like still need one more, or if it's not sunny, it just depends on the weather. So, but do get like several different times. You the sun's usually up in the morning. You could probably do it like before school or in the evening one day too, like not just at school. So, Okay, that one you can do. All right, that one you can do. Number 2, I'll do with you. Okay, look, I'll just kind of show you some of these. This one just wants a reflection rule. It tells you where you're reflecting it, which one says that. This one, it's asking you to flip it over the line y equals x. I'm going to go over that one with you as soon as you get your paper. We will do this together, okay? This one, it says flip it across y equals 0. This one you draw your, actually it doesn't really want your drawing, but what does it ask for? Your new ordered pairs. Does everybody understand that? All I want are your new ordered pairs. You probably need to draw it, so I put graphs at the bottom. There you go. Okay, so you can draw them all on here. This one just wants another transformation rule, super easy. This one wants you to do a reflection and then another reflection. I'll do one like that in just a second. This one's just looking at pictures, or these all are. This one, just they drew it for you and they want you to flip it over the x-axis. Just make sure you read it. Okay, graph it, flip this one over y equals 0. These are all doable, except for I feel like number 6 is new. So let me do one like number 6 really quick and skip number 2, but I will do number 2 with you. If you may end up needing one more graph. I don't know. All right, so number 6, I'm not doing your number 6, but I'm going to do one like it. It says, okay, we've got point P, and point P is at 3, 1. They want us, I'm going to do one very similar. Oh, you can't see it. There you go. They want us to reflect it over y equals -3, and then they want us to reflect it over x equals 1, because that's our new point. We're going to call it P prime. Okay, so let me just, what in the world, looks like a little foreign language. Don't freak out. All right, how about we start with plotting point P. So I'm going to go over 3 and up 1, and I'm going to call that P. And where do they want me to reflect that across? Y equals -3. Remember, that's a horizontal line. I'm going to draw that. 1, 2, 3. I'll just kind of do a little dotted line. That's y equals -3. Everybody good with that? How many spaces am I from it? 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. Just barely off the chart. That's my new point. We call it P prime. Everybody good with that? But crud. I've done that. I've done that. What are they telling me to do now? One more reflection. Okay, they just put 2 problems in one. They want me to take my new point P prime and reflect it across x equals 1. So let me draw x equals 1 is right here. Is everybody good with that? So that's 1, 2 spaces. So I'm going to go 1, 2 spaces. I'll call that P prime prime. Maybe. Everybody good? That's my answer. So if it wants your ordered pair, it might use the word vertices if it's a triangle. But what's your new ordered pair? Where's that at? Well, if I start here, I'm left 1 and then down 1, 2, 3, 4, 5, 6, 7. Everybody good? Yeah? We're ready now? Okay, skip number 2. I'll do number 2 with you in a second. And there's 11 problems.
Did you say y equals x is like?
It's a diagonal line. Y equals x is going like that. That's what number 2 is.
Which corner to start from?
Which corner?
Like instead of
On y equals x? Oh, I'll show you the trick to that one. That's why I'm doing that one with you. Here, Lakin. Hey, Lakin, you better not have any questions for me. Okay? Okay, and I'm missing Kaylee and Edward. Shane never came. He's not here today? I didn't know he wasn't here. I guess I just thought he was in the bathroom. Are all these people sick? Okay. Oh, I'll pause it for a second. Do y'all's problems. So for number 2, our points, let me find a bigger graph, because points are kind of, this one looks good. I think this will work. I'll erase that, hold on. And it's telling me to flip it over y equals x, okay. I hope that works. All right. Just for a reminder, I'll draw a little dotted line across y equals x so I can make sure that it looks like it's supposed to. Y equals x. There we go. All right. Now I will plot those points. And so it's negative 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. And then I've got 1, negative 3.
Negative 6, negative 3.
And negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So here's my triangle. And now I've got to flip it across that red dotted line. So it's kind of hard to count squares, although I would think, let me just kind of, I'm going to take a green marker and guess. Where do y'all think, since this one's 2 spaces, where do y'all think it's going to be on this side?
2 spaces.
2 spaces. Now, before I go any further, let's look at something. This one is over 1 and down 3. Where is this one at? Left 3
up 1.
and up 1. What just happened? What did you just switch?
The numbers.
Your x and your y. Y'all, what does that say? Flip it over y equals x. It just means switch your x and y values. That's all you're doing. Now, so it's like a little trick on that one. You could try to count. It's kind of hard to stay in a diagonal. Like this one I think is 2, no, it's not 2 spaces, is it? So you can't just count by that. But what is that ordered pair? This ordered pair was negative 6, negative 3. So what's it going to be over here?
Positive 6.
Negative.
Negative, switch them.
Negative 3, negative 6.
Negative 3, negative 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Does that look about right on my spacing? It does. So negative 3, negative 6.
So that'd be 6, negative 8.
So this one is going to be 6, negative 8. Oh, what am I doing? 1, 2, 3, 4, 5, 6, and down 3, 4, 5, 6, 7, 8. I hope that was right. What do we say? 6, negative 8. Doesn't that look about right? So see, sometimes you can even look. So the trick on that one, when it's the line y equals x, guess what you do? You just switch your x and y's, okay? And now remember, what does it want for your answer? It doesn't even want the picture. It wants those new ordered pairs. So you're going to write those 3 green ordered pairs that I have up here. What number?
Number 6. So when I go and do the second one, it doesn't move in this one.
It says you were at negative 2.
Do I need to put it?
You did
on
the first
positive
one?
side?
You reflected it over y equals negative 5?
Yes, ma'am. And then I'll go the second part.
So
R x equals 1 p9. Let's see.
what was your, okay, I'll just have to draw it. Is anybody still using this up here? Okay, give me just a second and I'll draw that first part for you and make sure. Anybody else though still need this?
I'm confused. It's confusing. It's like across the y-axis because if you're reflecting on the y-axis, it would be like that. But if it was y equals